This call is now being recorded.
Okay, Algebra 1, Module 1, Lesson 13. Lesson 12 was about solving equations, and one of the big topics was how do we solve equations? What are some of the rules, some of the things we had to remember? In this lesson, they're going to sort of affirm those things. In other words, they're going to build on those things. What you do on one side, you must do on the other. And we're also going to talk about how properties, number properties that we've learned throughout this first semester come in to be a big component of explaining how we go step by step by step. Here in your textbook, in your workbook, lesson 13, you can use that as we go along in this video. And we're going to do a couple of the exercises, starting with number 1. Number 1, you'll see they give you an equation, and you can see it sort of pyramids down to an answer of 20 equal to 5x. They don't actually solve it. But the point of this is they want you to describe the property used to convert the equation from one line to the next. I have the solution for you already. So for instance, let's talk about number 1. You'll notice that from the original, the only thing that's happening here is that you're multiplying and distributing here the x through to get an x minus x squared. Everything else stays the same. So that's why this first property is just the distributive property. Moving from the second line to the third line, you'll notice that it looks like, if you look close, it looks like they're adding an x squared. They're adding an x squared to both sides, eliminating the x squared. And so that's why it just sort of disappears. What they do on one side, you must do on the other. And they added an x squared to both sides. That left them with x plus 2x minus 4 is equal to 8x minus 24. And so we want to know, well, what'd you do from there to there? It appears that the only thing that's changed is in this area right here. Well, and that's why we say, well, they've added like terms. And so we're explaining each step, which is what you're going to have to do in this lesson. And then finally, from 3x minus 4 is equal to 8x minus 24, how do they go from this step to that step? Well, turns out that we're really just adding 24 here and adding 24 here. And that's how come we get the 20. The 8x is untouched, the 3x is untouched. And that's why we say, well, you're adding 24 to both sides. And then finally, from 3x plus 20 is equal to 8x to this, all we are doing is we're simply saying we're subtracting 3x on both sides. And that's how come we get to this. Now, if we wanted to finish this out, we would just divide by 5 on both sides, and your actual solution set would be x is equal to 4. In this particular problem, they just want you to explain each step, and you're going to have an opportunity to do that during this lesson. And you can pause the video, make sure you get all that down, and then restart it. In fact, we're going to solve 2, and I'm going to explain what I'm doing, and we should be able to write or abbreviate on the side. So let's start with number 2 here. This is from your book as well. Solve the equation for x. For each step, describe the operation used to convert the equation. I'm going to voice it, and then off to the side, write a little annotation. So my first step is to follow. I've got to look inside here. So I'm going to distribute the 3 in here and here. So it doesn't look terribly organized, but what I'm really doing is this. I'm distributing this negative 3 into x minus 1, and I get 3x minus. Everything else stays the same. However, this becomes minus 3x and a plus 3. Everything else will stay the same. My next step, I'm going to work inside. I'm going to focus on staying inside the parentheses. Is there anything I can do in here? As a matter of fact, I can add the 8 plus the 3. So keep that blue minus inside. I'm still working on the inside. I'm going to write it as negative 3x. 8 plus 3 is a plus 11. I'll come back in a minute, and on the side, I'll put the reasons. In a minute, I'll put the reasons on the side. I keep solving. My next step is I'm going to go ahead and leave the 3x out here. I'm going to distribute. I have to distribute the negative in here and here. I have to get rid of the green brackets. And so negative times negative is a positive 3x. And negative times a positive is a negative 11. So we're slowly but surely getting to the solution. I notice that I can add like terms here to get between these two and get 6x minus 11. And then again, now I'm going to have some choices to make. I'm going to choose to move the x's over here. Obviously, this goes to 0. I'm now going to be adding 11 to both sides. And that gives me 5x is equal to, that's going to be 30, divide by 5, and my final answer, x is equal to 6. Now, in each one of these steps, I should be able to explain what I'm doing in each one of these steps. And so just to go back, in this first step, what did I do? Well, in the first step, from here to there, I used the distributive property. In the next step, I used the distributive property again with the negative. So from here to there, I distributed the negative through. So distributive property gave me the negative 3x plus 3. What did I do from there? Actually, I have to go back. This step actually should be, I added like terms. So as I go back, I recognize that, wait a minute, I added like terms here. Because that's where I went from here to there and got the plus 11. Add like terms. Then I distributed the negative through, and that's what we put here. And going from this step to this step. Well, it looks like we're adding, or rather from this step to this step, we're adding like terms again. Adding like terms. And then finally, it looks like we are using the subtraction property right here. So we're using the subtraction property of equality. And then the addition property of equality. And then the division property. All of these properties, the distributive property, the addition property, the subtraction property, the division property, adding like terms, all those things allow us to solve and get x is equal to 6. That's number 2. And we're going to start number 7. We won't finish it, but this is from your book again. Let's consider the equation 3x minus 3 is equal to 5. The first thing it wants us to do is multiply both sides of the equation by a constant. And so what I'm going to do is I'm going to choose any constant. It doesn't really matter what it is. I'm going to choose in number 7. I'm going to choose, what should we multiply by? Let's multiply by 7. So we're going to multiply by 7. So I'm going to take this x minus 3 is equal to 5. And I'm going to multiply both sides by a 7. So that's my first result is 7 times x minus 3 is equal to 7 times 5. Okay, now multiply both sides. We've done that and show the solution set did not change. Let's just plug a number in just so that we can prove the solution set has not changed. So for instance, if I just choose the number 8, let's choose and just plug in 8 for x. Should be equal. Eight minus 3, is that the same thing? As a matter of fact, it is. So we've shown that this does not affect the solution. Now let's multiply both sides by x, the book says. So it says now multiply both sides by x. So let's come back up here to the original. Give yourself some more room here. And what I'm going to do is take what I originally had, x minus 3, is equal to 5x, or 5x now, and x outside. So we're going to multiply the original, and we're just going to multiply an x there and an x there. Will that change the solution? Let's find out. So in B it says, show that 8 is still a solution of a new equation. So let's now take and put 8 in and see if we get the same result. Here we go. 8 minus 3 is 5. And in fact, this doesn't impact our solution. These are still equivalent. And then finally in C, the last one we're going to do on this video, show that x is equal to 0 is also a solution. So now we'll take the original x times x minus 3, and we're going to put 0 in. Show that 0 is also a solution to the equation. And so 0 0, and so 0 minus 3 is negative 3. Negative 3 times 0 is 0, just the same as 5 times 0 is 0 as well. And so we have shown in B and C that just multiplying by x on both sides does not change the problem. However, as we will see later, it doesn't hold true for everything. That will conclude the video for right now. We'll have some more discussion on lesson 13. Enjoy.